Hello, everyone, and my name is Vladislav Antonyuk. I am a senior software engineer and also Microsoft MVP. So today we will talk about source generators. I will show you what is it, why do we need it, how it can help you to solve some issues that you may have in your project, some issues with duplicates. So let me share my screen and let's start our evening today. So, okay. Yeah, of course, you can touch me in LinkedIn, or you can find some useful articles on my website. And as today we will talk about source generators, and let's jump to our code. So let's first start from the problem that I had in my project and how we solved it. So our task was to create, we need to track some changes in our database. So when we delete some entities, when we create, update some entities, we want to log all actions and see the history of all changes. So we used entity framework, and for that we usually have a DB context where we have a DB set, we have a connection string, we set some data, etc. And we also have some model that we want to store. So our program CS class looks like this, where we initialize the DB context, where we create database and start adding and updating some changes in the database. So for tracking, we tried to find different approaches. We tried with a default approach from entity framework without any additional database using temporal table. Also, we tried with auto history library that allows us to do pretty much the same, which with enabling auto history extension, and that actions automatically done when we it works like interceptor. Also, we found that audit.NET library that has much more configuration, so you can choose which properties you want to save. So in case you have a rather big entity that you want to store and you don't need all properties, or you want to store some additional properties like user, for example, who initiated these changes, this can be done in audit.NET library. So for audit.NET library, we needed to create additional class that will be like additional table that will be storing all information, all that history. Well, for that, we also need to create additional DB set, edit interceptor for audit save changes interceptor, and our code also required some configurations for this library, where we need for each entity, we need to add explicit mapper and map each property, so from our initial entity to auditable entity. And for one table, it may work, but what if we have 5, 10 entities? So this code will be duplicated. And we do not want to duplicate code. We want to somehow automate it, so all these additional configurations done automatically. For that, in .NET 5, Microsoft introduced source generators. And I will start with the initial implementation of source generators. So in this project, we still have this classes that we want to have. We have still DB context with some interceptor. So our source generator that we will use will also based on this audit.NET library. And our task is to automate this mapping, automate automatically generate some code instead of writing it manually for each property. So for that, as you can see in this project, how we edit it, we still have this class, we still have a DB context with only one DB set. We still have a program CS file where we have all these configurations. So these changes remain the same. But for this project, we implemented a source generator. So source generators, it's like intercepted. So this code, this feature, let's say, allows you to auto-generate code based on, so you write code that will generate another code. So it's done during the build time. So when you build the code, you get some auto-generated code. So it's like some step in your MS build tasks. And which problems it solves? Let's take a look at this beautiful article. So source generators allows you to have more capabilities. It allows you to remove some performance penalties, especially if you use some reflections tasks. As for downside of it, it requires more development time because you need to create a project. And also another issue that you may have is that it allows you to, so you need to learn how to write it correctly. And let's back to our project and see how to create source generators. So first of all, to create source generators, you need to create a .NET Standard 2 library and add these two packages, Microsoft Code Analysis Analyzer and Microsoft Code Analysis C# Workspace. So these two packages are required. And after that, you will need to create and implement iSource generator interface. As you can see, it already ReSharper suggests me that there is an issue that seems like you're using an old implementation and you're using source generators instead of source generators, and analyzer suggests that it's an old solution. So let me probably zoom a bit. And first of all, I will start with the source generators, and then I will show you what is the problem with it and what is an alternative solution. So, but the idea of source generators is the same. So as for source generators, first of all, we need to initialize our context. So we register for syntaxes notification and say that what target type we will track. So source generators actually track all changes in all your files that you have, and based on the actions that when you start typing, it start analyzing your code and generating it based on this syntax context receiver. So here we can allow to filter what type of changes do we track. So for example, here we are looking for context, which is a type. So we are looking for specific type, and we are looking for type that is decorated with attribute. In this case, attribute audit. If we back to our model, you can see that we added this attribute. And let's back to source generator. And what is this attribute and how it's generated? So we automatically generate this attribute based on source generators. And for that, the execute method will be executed each time when you make some changes and generate this code. So for context, for generator execution context, we add source. So we say that we want to generate file with this file, and we write the code like a string. So that will automatically be generated by source generator, and just text that will be written in that file. So what we have here for attribute, we just generate a standard system attribute. And that's pretty much it. As for the next auditable, it's a base class that we will use. It will be base class for all our entities. It's an abstract class, and it will have all these additional properties that we want to track. For example, we want to track user ID, client ID, date, when we made some changes to the database, for example, and some action type, if it's create, delete, update operation. So after generated all this and adding all this context to source, the next step is to search for syntax, search for all auditable types that we generated. So we source generator will automatically search for all classes with this attribute audit, and we start generating code for it. So our task to generate this file, audit client, with all these additional properties. Another task is to generate this DB set, additional DB set for our DB context, and also create the method that we call once to map all our entities. For that, in source generator, we start getting auditable class nodes. So here we are start looking for all, going through all our declared symbols in our syntax tree. So in generator execution context, we get compilation, we get semantic model for syntax tree, and get declared symbols. So we get all symbols, and we are looking that it's a class. So for that not symbol, we extend namespace. We get all and we start initializing our class, like creating our class. So we add usings, we add namespace, we define our class based on our auditable class. We add in this identifier property, adding some additional all properties that we had in base class. So we want to get all of these properties that we have here and automatically copy them into auditable entity. And after that, when we defined it, we also, for entity framework, we also need to create a configuration file that will define all, like adding some key or add additional configuration for some properties if we need. And as a result, we return our generated code for this class. We also return the name of the class and name of the generated class. Name of class, name type, not symbol name, is client in this case. Generated class name is what we generated here is audit_client. Back to our generators. The next step when we edit, when we get the result, we add this type to our collection and add this class to our source. So we generated this class. The next step to generate our DB context and generate extension method. So for DB context, we generate DB context the same as for previous class. We also need some usings. We define DB context. Also, as you can see, now it's required to be a partial class because we like add additional properties, additional methods. So it will be, it's required to be a partial class. And we add our DB set for this type. And we implement override our method on audit model creating, where we apply our configurations that we just generated in previous step. And the last step is to generate audit mapping extension that will map automatically all our properties, all our entities. the same, we generate static class, generate extension method, map auditables, that receives iAudit entity mapping, and that class for each type that we generated, we just call map method. And that's it for this source generator. As a result, what we have here, we use some extension methods like for building properties. So just as a result, when we created our source generator, the next step is to add it to our reference for this project. For that, we need to add project reference. But because our main project may be .NET 8, for example, or some other for other target framework, source generators still require to use net standard. So that is why we need to first of all set target framework net standard. Also notify that output item type is our analyzer, and we do not want to reference output assembly. Another step is that it's optional, but very useful for debugging purposes, or just to see the track what source generators generated for us, is to add compiler generated files output path. That so it's a path where our files will be stored after they are generated. And let's now see what actually you can find. So I use Rider because it has a separate folder, let's say, source generators. It's really easy to see what's actually generated here. In Visual Studio, it's the same, but for some reason, well, Rider works better with source generators. And as a result, for source generator, we can see that we have an audit generator, and it generated all our entities, all our classes that we asked him. First of all, it generated audit attribute. Then it's generated our abstract class auditable that we will use to inherit all our auditables. Then you can see we have client 2 and client, and together with the configuration for it. And the next is DB context, that is a partial class with DB sets for these auditable entities, and also applied all configurations. And of course, the last step is to call map method, extension method for all our entities. By that, we automated our process of generating all entities. And for example, here, if we add audit attribute for our client 3, you can see client 3 automatically appeared with all configurations, with all properties it has. Our DB context also updated with additional DB set, and the same applies for mapping, where we see another mapping. So after some pain with creating source generator and some magic strings like this one, where you can add some usings, etc., namespace, you automated your process of generating some entities based on some attributes, so that automatically generated. And for example, where you can also use it, you can suggest that it can be a DTO, where you have like a main model, and you want to create a data transfer object, where mostly all properties look the same. Also, I had a project where we need to, based on the attribute, validate credit cards. If specific property had a credit card, with the base solution, we needed to use reflection. You know, reflection is rather slow compared to the compiled code. So with source generators, we just generated like a dictionary where we have a property, we have a value, And based on these values, we generated and validated all our properties that needs to check for credit card in it. And it all looks good, but Microsoft goes further and implemented incremental source generators. You may ask why that happened? Because of a performance issue with source generators. So let's take a look at this generated file. You can see that it has a time 7 p.m., 7:30 p.m. And let me now, for example, remove this attribute. You can see it disappeared. And back to generated code, you can see the time changed. So, for example, now for client 3, the entity that is not auditable anymore, I rename name to names. And let's now back to DB context and see that the time changed. And that is a main issue. So whenever you type any symbol in any entity, it doesn't matter it's trackable, not trackable. For example, edit for trackable as well. You will see that time actually changes, and that is a problem. Imagine you have a lot of files, and it usually takes up time to just analyze all your code. And with source generators, it still tracks all your files. And that is why Microsoft in .NET 6 implemented, or 7, probably 6, added incremental source generators. The idea is pretty much the same, but the approach is a bit different. So for this project, it looks pretty much the same. We have a client 2. So idea of this project, nothing changed here. All changes happen in incremental source generator project. So now we're back to our generator. And now we need to implement incremental generator. Idea is the same. We have initialize method that initialize our source generator, incremental generator. And here we register some events that happen, like steps of source generator initialization. First of all, we register post-initialization output. So just when source generator initialized, this code will execute it only once. So difference already here from generators, where this code execute each time, this code will execute only once when source generator initialized. The next step is because in 99% probably source generators are looking for attributes. So Microsoft for syntax provider implemented specific method for attribute with metadata name. So where you specify the name of the attribute and it will automatically search for all here in predicate. So in all classes in our declaration, it will search for this attribute. So if your class doesn't have this attribute, it will not track this entity. That is another boost of performance. So the next step here is transform. So for when source generator found this, passed all these steps, so it found class declaration with auditable attribute, it will call this transform method, and it will return incremental values provider. And here is also important step. I will talk about it a bit later. So the next step is for looking for another auditable types here as well, and we register for source output. So once we found these types, auditable types and other auditable types, we want to execute some code, and in execute method, the logic is pretty much the same as we had in general source generators. So where we generate some classes and we add it to the source context. The same idea is applied for, so we register the source output. And once it's executed, after all these steps run, where it's generated source output, at the final step, we register implementation source output. So based on the output of the source generator output, we can call additional code and apply changes for looking for all additional classes that were generated previously. And we have added client DB context modification and implemented additional auditable mapping extensions. So idea of generation code remains pretty much the same. Here we also get types to generate. We search for some types. And let's now look how it works. So this is the next project. This one, Incremental Source Generator. And let's see at source generator folder. So let's make some changes to our models. Let's say add names, add, and take a look at, for example, client DB context. You can see the time now 6 p.m. It's the time, probably UTC time. And let's make some changes. Let's try to see again. I don't remember if times changed. Let's try again. Let's add some properties here. Let's take a look again at client auditable. Yeah, birthdays. So something changed here. You can see the time changed, but our DB context remains without changes. So last time it's generated at 6 p.m. Why it's happened? Because our code is cached. So actually client DB context and changes in this property does not affect changes in this class. So that is why there is no need to regenerate this class again. And you can see that time here has changed. So that is the main changes from source generators. And the benefit of incremental source generators. So it will only regenerate files that are actually needed. And for example, when we change client 3 that is not auditable at all, nothing changed. When we add audit attribute that we generated, it takes up to some 2 seconds. So we see that our auditable class appeared. Let's take a look at DB context. You can see the time changed, and that's it. So when we remove this property, client 3 remains, client auditable time changed to 7:39. Remove this property, but for example, DB context time remains without changes. And that is the main benefit of source generator, incremental source generator. And let's see how it works. Another awesome article by Andrew Locke. It's even better than Microsoft's documentation. I highly recommend this 10 parts to deep dive into source generators and how it works. All the steps describe all you need to know about source generators. And here is a picture demonstrates how actually source generator works. So Andrew created source generator to create a fast enum library that will generate all text implementation or numbers based on the enum, based on enum extensions property. So for general scenario, right, when we have just enum, where we have enum extensions class. So it source generator found this attribute and selected all values that it had, generated, and register source output generated source. What happens next? We, for example, added another class. So we again looking for changes for attribute with file metadata. We found this my enum. We see that code and all like we have first, second. That's it. Nothing changed in this enum. No need to regenerate the file. So generation skip. The next step is we added another enum into this enum. And what happens? We found that this enum again for attribute with metadata. We selected it. We found that it differs from what we generated, and we need to generate a source. So how it's understand that it actually changes, and actually it validates based on what we stored for source generator. Let's back to our source generator and see important part here. The most important part, because if you just store all like all this data that you want to regenerate, for example, here audit to generate is struct. For example, if you store it as a class, because class compares based on reference, it will have different references, and your code will be regenerated all the time. And you back to the performance, well, you will have an intermediate performance benefit. So it will be better than source generator that will regenerate all code and analyze all code. But you will still regenerate all your files that you have here. And actually, it is not what we actually want to get from source generator. So it's very important to implement it correctly. So to make it cacheable, let's say, we have a read-only record struct where we will store all entities that we need for future generation. So we need to store namespace, name, and property types. That is all we need for our entity. We need namespace, we need entity, we need a name of the type, and we need property list. That what we store, and that information will be cached in source generator. So we return incremental value provider for this audit to generate. So how we generate it? Get type to generate method. So we again found name type. We get all members of it. So we store field name, we store type, and we store all its properties. That's it. So, but how we get this cached? First of all, it's need to be struct. And we need to copy paste some code from Microsoft, from .NET Standard 2.1 or .NET 6 or later. So we need to equitable array. So because it's implement equitable interface and it has a correct implementation of equals, it's highly performant because it's use spans. That's code just a copy paste from Microsoft and without any changes. We also need a hash code class. It's polyfill for .NET 6 hash code. And it also allows us to make some comparison. And it's a downside of like using of source generator that is still .NET standard. Unfortunately, we need to copy paste these two classes, equitable array and hash code, to our source generators. So yeah, as for generation code, the class remains pretty much the same without changes. If I'm not mistaken, it's pretty much the same types, probably just different parameters, but idea is pretty much the same. We generate this code. So that's it about source generators. We generated all these values. It's performant. We remove something that's changed, only what we actually need to change. So the last changes were at 746. For example, if we look at client 2, it didn't change from this time. So our implementation works correctly. This entity cache, it was not auto regenerated, and all other entities, all other classes were generated. Yeah, I didn't at the time. So for this part, let's see if you have any questions about source generators, and let's see in our chat. Yeah, thank you, Diana, for don't forget to donate. It's really important for Ukraine.
Yeah, and we have 2 questions in the chat.
Yeah, where we should use reflection and where use source generators. So I highly recommend to use source generators where you can use it instead of reflection, but where it actually makes sense, where you can use source generators instead of reflection. For example, like you cannot create an instance of your class based on source generators, right? You can use like activator from reflection to get some type and create it. But for example, even Microsoft uses source generators almost everywhere now for the last 3 years when it appeared. So all your regex implementation uses reflection. Serialization from system text JSON uses serialization. Another examples where actually we use in .NET MAUI, also in Community Toolkit. You probably know me from Community Toolkit MAUI. We also have a text color 2 generator, and it's also incremental source generators, which automatically generate all extension method for these interfaces. So it's highly used now, and as I mentioned, it's also can be used in. So where you can use source generators, it's better to use them, but you can probably see if a performance, you should compare performance first of all. If it's just a one task to probably create, I don't know, you use mapper, for example, based on your reflection, you have some implementation, for example, from AutoMapper, which use reflection, and it works for you, probably just use it. If you see that performance degraded when you use reflection, when you probably need to track a lot of properties, you need to retrieve some additional metadata, additional types, whatever, I suggest you to use source generators. So that's my suggestion for you. Let me ask a question. Is it possible using the code generators feature to remove existing code that was written by developer manually? Yes, but once again, you need to write that code that you want to replace. So it is not like a full replacement. So source generators just allows you to remove some at least from my examples. Yeah, we just need to replace duplicated code. So when we see that some codes duplicates, we can replace it and automatically generate it. You can, as for replace remove in .NET 9, no, in .NET 8, there is a preview feature that allows you to replace the method at build time. I don't remember exactly the name of it, but it also based, it's pretty much similar, where you just allows to replace some existing code the developer wrote. If you give me a few seconds, .NET 8 preview feature. Don't remember the name. What's new in .NET 8? There were an experimental. Oh, probably I will not find it really fast, but or probably here in C#12 interceptors. Yeah. So as if you're talking about, is it possible to use in code generation to replace removing existing code? Probably you can take a look at interceptors. It's still in preview, but its idea is very similar, where you it allows you to replace. Oh, actually, you can use interceptor as part of source generator to modify. So in combination of these two features, you can probably achieve what you want, but it's important it's in compile time. When reflection is actually a runtime, so here it's a compilation time. And back to the previous question, when you should use reflection, when you need to change something at runtime, which is not possible during with source generators. Source generators are just for compile time. That is why it's more performant than reflection. What do you think of combined benefits of AI in code generation and source? Actually, artificial intelligence it's really popular nowadays. That is true. But probably it will help you to write source generators. Because from Microsoft, I haven't found a good documentation about creating source generators. It's available at GitHub, on GitHub docs, but not at Leon Microsoft. That is upset, maybe because Microsoft has awesome documentations for mostly everything except source generators. So as for AI, probably I don't think you can actually AI can just help you to generate code, but because source generator is actually compile time, you will not get something that work as you want. And I can imagine how you can combine it. Probably if you write some source generators that will combine it, that's good. You can present your presentation in the source generator and Svitla systems. And let me ask another question: how to unit test the generators I wrote? Yeah. As for source generators tests, I didn't prepare the sample for it, but it's also possible. Probably here or not here. Well, analyzers. So the main question probably you can search in this repository. If I'm not mistaken, we created unit test for source generators as well, probably this one. But the main question, what do you want to generate here? What do you want to test here? So you can, so main idea of source generators to just generate your code, and how you can test it, you can still cover the logic that you have for generated code. So the code is generated. So how you write unit test for it, it's up to you. So you can generate some class based on your implementation, a mapper. And for example, here you can write a test that will create client, run some method, and that will validate that auditable entity appeared in database. Maybe it's not a unit test, but like more integration tests. but that is how you can test it. Also, as for it will not a unit test, it will be more like a manual development test, right? Where you can just open a source generator, see that times appeared, you can open and see that all properties here, you can rate it correctly. That is probably more than enough. So the main idea of source generators, not to like test it. So as from my point of view, you do not need to test and cover all source generators at all with unit test. Probably it's another task. I don't know what you want to test here. But yeah, it's technically probable. It's you can test it like all other like classes. So here, yeah, it's still a class. You can create an instance of it. You can call some methods and see. But the main question, what you want to test here? What is the output of your test? And the next question. What parts of C# code are the most approachable for source generation? Let's say you go look at your project and immediately see what we can reinforce with stack. As I told that the best part, you can see that some codes start duplicating, or you start using like TTOs and models where you duplicate the same class multiple times. You need some additional configurations with entity framework, like in this example. So this example like looks pretty good because it covers a lot of different cases how you can automate the process. So you just add attribute for your next entity and you automatically generate a DB context. You generated some auditable entity, some extension methods. So it depends on your project, on your task, and I cannot say that you should. Well, you have a hammer and you start use it everywhere. Yeah, for all your problems. So you have source generators, you know about it, and you try to use it everywhere. As for me, I started using it about 1 year ago, and first time I just saw that, well, we have this task, yeah, that why not to try to use it? Because when some features first implemented by Microsoft, as for me, I didn't know where I can use it. I want to use it probably because it's like a new feature, it's modern. Microsoft advertise it and try to make it really popular. It demonstrates its benefits, but I didn't find where I can use it in your project. So probably after you get some experience, when you analyze your code, probably you see that source generators can be used here, for example, for reflection. As I told that in case you use a lot of reflection in your tasks, in your project, maybe it's a right place where you can at least some of them may be replaced with source generator. And yeah, that's it. You have nearly convinced me. This writing a lot of strings and elevate the public course. Is writing a lot of strings and only. Yeah, so benefit of source generator, yeah, in case you have you need to create you know that you need to create at least two, for example, track in this example, track just two properties, two models. Probably creating a source generator will not bring you a lot of benefit. In another project that I told where we validated the source credit card in property, we had 5 models with about 50 properties in each of them, and only 3 of this property didn't need to use, and they so this properties map from CSV file, so we do not know which property exactly we get because of abstract class based on file, so a lot of different information. But the idea that we needed to we need to get, for example, if we found the credit card, we need to identify in which property, in which file, on which line of code, in which line of code, not code, like file, we found this credit card. And first solution was using a reflection where we get all properties and then we validated the credit card for each of them, and this CSV file may have 10,000 items, so it's a rather big file that we loaded. So our validation took about 1 minute when we used reflection. With source generators, we improved performance up to 17 times, so it now takes about 5 seconds, 5 seconds to validate the same file. That is much better. And compared to the also memory usage, probably reflection, first of all, it's slow. It also requires some memory usage. With source generators, we already get the entity ready for validation, and we used it. Yeah, but as we have no more questions about source generators, the second part that I want to cover is a downside of source generators that I faced when I tried to use it in my another project. So with what a benefit. So yeah, benefit after compilation, you get compiled. So you don't need to use reflection. Reflection is slow. So compared to like runtime and compile time is much faster because you already get like compiled code. Yeah, you do not need to track and analyze it during runtime. Yeah, and so everything is good with incremental source generators, but the problem that it only can generate three types output. So actually generator, the second parameter here that it receives, it's first language and additional languages. So source generators can generate only C#, F#, and the Visual Basic output. But so you cannot, like, if you say that you want to add some GS, it will not work. So it will generate your file, auditable CS, GS, and automatically add CS. So that is a problem that I faced in my project. Let me move it down. So how I solved the issue and what was the problem? What I want to achieve? So I have a project that is a plug. So it uses plugins with the microkernel architecture. It's a project 𝐬𝐥𝐚𝐝 for automation. For automation general tasks, routine tasks. So the idea is pretty much the same here. So I had a base class, I have some extension, a plugin, and I dynamically load them based and looking for this export attribute with some metadata. So my idea was to generate some kind of file, plugins JSON file, or some other like type. First of all, I want to implement it. I thought about source generator, so that based on this parameters, I will generate a metadata class that I will use at runtime to get the instance of to get the metadata of this plugin. But as I told, that source generators can only generate CS file, and I didn't want to use reflection, so just want to avoid it because you know that plugins, there may be 1,000 of them, and I didn't want to like load each plugin each time to just check if it has this extension, getting its information, etc., etc. So I decided to create a plugins JSON file that is embedded into this plugin that I can read at runtime just to get the metadata of the plugin, and later when user runs some action based on this plugin, it will be only then it will be loaded. Of course, this time using reflection, because it's the only way to create an instance of dynamic type, and that's it. So I created a plugins JSON file. How I created it? So in this case, I used MS build task. So for that, it's like probably for you when you need some changes. So like me, for example, can create another type of file based on what you have in your project. Problem is MS build is the only solution that I actually found and was suits for me. So for that, you need, in that case, add two NuGet packages. First is Microsoft Build Utilities core, and the second one is Code Analyzer C#. This one will add you MS Build task, and this one will just allow you to use a C# compilation. So the next step was to create so how it works. The idea of this MS build task just to create this output plugins JSON file. So using, I just started from the first lines just to create and manually creating a JSON file. So the main idea here is to parse and generate actually the code that we have. So MS build, actually how it works, it's actually like an executable that runs into the project that reference it. For example, here you can see that it reference a package reference to this MS build project. And when I build this project, it executes the task of MS build and generate this file. Let's back to program CS. So idea here is to get compilation. So it runs into the same directory as a root directory of this project. So we search here for all CS files. In this case, it's just start CS. Also some filtering for all files that we found. We are reading all content. We are finding if it contains, in my case, base class macro command, and we parse C# syntax tree. So on this step, what we get a syntax tree, and that is pretty much the same that we start getting from source generators. So we get a syntax tree, we get a compilation. So the next step is we get C# compilation. We create some temp compilation based on this syntax tree. We created a temporary dynamic link library. We also need some references to it just to make sure it compile. And we return this compilation. So the next step, when we get compilation based on syntax tree, we start parsing and going through all these nodes, class nodes that we generated, and then logic goes deeper when we get some attributes. For example, you can it's already a method from name time symbol, so you can get some attributes. So you just start parsing your actually code. So you get this class name, you get all properties, you get these types, you get some methods if you get. So you can actually get all the code. So for example, here build properties, you can see that it gets symbol, that is a class, it gets some attributes if necessary, like namespace, name, environment join. So it's up to you what you write here. So the idea is here you already start working with the parsing all your classes, getting all properties, getting all your symbols, getting some attributes. All of that is available from this code analysis C# library. And the final step, you generated this file, it's appeared here. Why it's appeared here? Because in a MS build, you probably know about props and targets files. So target is like steps that you have in MS build pipeline. So in MS build pipeline, it actually like a middlewares, right? If you know about ASP.NET Core, so you get some steps. For example, this one writes before targets build. So you have a target build right before we start building this library. It will execute command this MS build, this file name. So it will run this MS build task and add this plugins.json file that generated after it as a content and copied it to output directory, writing some message. When we want to clean, for example, let's clean it, delete file, it deleted. Now let's build. And we see that first step is restoring some items. Next step will be running generate plugins.json. And the final step after build, it will just build and this plugins.json file will be appear. So it's generate base file. Let's give it some time. Success created package. So what's happened here? Yeah, we build started for this project. The next step is before build, it's run this script and generated some JSON. We received this message generated. Yeah, this, and after that it's built and generated Nugget package. So you can see that plugins JSON file appears. So idea here is pretty much the same as, so it's my kind of implementation of source generators and task that I want to achieve. And unfortunately, source generators, as I mentioned, does not allow you to create a file, not C# file, or not Visual Basic or F# file. So alternative solution, you can use them as builder and achieve pretty much the same result. Also, you probably hear about TF4 templates or some other libraries that allows you to achieve pretty much the same result. I decided to use what we get out of the box, like source generators and MS build tasks. It's probably the latest version, the latest solution that you get from Microsoft, and that is why I decided to use it. So that's it, what I want to show you today. Do you have questions about the second part?
Okay, we have one question.
Yeah.
Yes.
I have another question regarding the first part. Okay, are there some community solutions and employee source that there are a lot of community solutions that that use source generators, generate source generators. One of them is Microsoft, of course, because they use it for regex, they use it for system text JSON. Even if you open some project, some dependencies in here, probably it's in analyzers, you can see source generation, import generator, source generation. So, and it's just a project without mostly any reference except these two projects. So already there are a lot of analyzers and generators used by Microsoft. As for Another source generator libraries that I used is a mediator. You know, library. So if you use library mediator, yeah. So it does not use source generators, but another library called mediator source generator. Another library calls mediator that is based, and it's pretty much the same library, and it's based on mediator. And you know, 𝐀𝐧𝐭𝐸𝐬𝐥𝐚𝐯 also have a video about it, the difference between two of them. And mediator, this library is faster because it's used source generators. It does not need to, you can see the comparison. Yeah, so let me zoom a bit. Baseline, mediator, and mediator. So you can see, first of all, mediator for send request. Baseline, it's probably about without using reflection, just without any library. Mediator, don't know about this too. So, and mediator. First of all, it allocates some memory, then it's slower up to 5 times, or 50 times. Yes, so you can see that source generators has its benefits. Here, when you use Sprint, you can see that much less memory allocated and faster. So I probably imagine that some of you use mediator, and you can take a look at this library. It has the same implementation, but just using source generators. So it's also rather popular. It's actively supported. It's has this version 3 in preview, so you can, I highly recommend using this library instead of mediator. Yeah, high performance .NET implementation of mediator pattern using source generators based on mediator library. And migration from mediator to this library will be just changing 2 or 3 files. Another example of really popular libraries, automappers, but automapper does not use source generator, and it uses reflection. And if you see the benchmark of automapper of mapper libraries, automapper is not the high performance library. And the most performant library is actually when you don't use any library and just using one-to-one mapping in your code. And if you use some other implementations, so there are a lot of libraries that use source generators for automatically map your code. Probably Mapster, if I'm not mistaken, use it. Another example, I don't know, enum generation that you show, fast enum library, or probably mostly all libraries that end with fast, or like fast enum, fast string, performance string, something like that. They all use source generators, so it is very popular. And I believe more and more libraries will appear because like source generators solve, like as I showed here, compared to reflection. Yes, reflection faster to implement, but performance penalties. And easier to learn, right? Mostly you get property, get metadata, create instance that all you need to know about reflection. But fewer capabilities, more performance penalties. Source generators, more capabilities, fewer performance penalties, but pros of reflection becomes cons of source generator. It requires more time to develop. It's probably more difficult to support it, right? Because first time when you, probably even when I showed you this code, it was probably rather hard to understand what happens here, right? When we need some usings, something not generated, something goes wrong. It's probably harder to see what happened here and maintain it. The good thing that you can debug this code. You need, I don't, actually this part will, you can find documentation in Microsoft how to run it. You will need to install Visual Studio plugin, not plugin, like some extension from installer of Visual Studio that will allows you to Roslyn debugging, something like that. That will allow you to debug your code, debug your source generators, and it should simplify your life. Okay, let's see another questions. Should another developer to extra configure dev environment when user is built? No. I need to spread custom generator. If I need to spread the custom generator, can I share it via Nugget package? Yes. So it's actually not, there is no difference. It's actually just a library. So you can generate, yeah, you can need to add some additional like crosslink component, enforce extended analyzer rules because of Microsoft issue. But overall, it's just a library. So this, so when you run .NET Pack, it will just create you a Nugget package that you can publish to Nugget or your own Nugget. And when you edit, just pay attention that you need to. Probably it will, when you add the package reference, probably it will include like add additional like assets, private assets for you, like include analyzer or not. It's up to you how you edit, and if you edit as a project reference, when you in team develop a source generator and want to use it in the same in the same solution, just add these 2 lines, 3 lines. Set target framework, otherwise it will not run and will get you some at least warnings or probably even errors, or will not just generate code at all. You need to add output time, output item type as analyzer, so it will understand that what actually is a project reference. Otherwise, it will include its assembly to the output, and because it's runtime, you do not need to get this reference into output published directory, and of course, reference output assembly false. As far as an increment is implemented rather recently, what future development in this area could be? Incremental source generators implemented the next year after source generators. So if source generators implemented in .NET 5, the incremental source generators appeared in .NET 6. So it's already 2 years of incremental source generators. As a future, probably for now, the best to get the future of source generators is to track what happens with issues on .NET Roslyn Analysis repository, where all of them live, and see what is the future. There are some open issues, so probably they will be resolved. But as for major changes here, first of all, people should start implement it correctly, because actually even when they migrated to incremental generator, as I told, most people don't use it correctly and still get regenerate the code each time they start typing. So any symbol they have, yeah, they still they don't get the benefit of incremental generator. So probably Microsoft should start better add documentation. I wish they also add update at least net standard to .NET 2.1 at least. So we do not need to copy paste this equitable array, this hash code class, or it's from .NET 6. So probably the next major changes maybe they will need to update the target framework that is used. They used the .NET standard just because it needs to work with .NET framework and some compatibility issues with the previous solution. So probably that is the issue why they still using .NET standard. Maybe as for me, the major problem here is that it still uses .NET standard and not .NET 6, .NET 8, or whatever. There's a few more major versions. Maybe in some future, when they stop supporting .NET framework, maybe later and start only using .NET, then we will see updates here, but probably not in the nearest future.